Hello, I'm Larry Sharp, and I'm one of the application engineers at Chroma System Solutions. Today we're going to be talking about how to simulate power line disturbances. Power line disturbances are defined as any variation in the AC voltage, whether it's in the amplitude of the voltage and a variation in the frequency, even the waveform itself. So power line disturbances also have other related terminologies such as sag and surge, harmonic, interharmonic, transients, and noise. So sag, swell, outages, short interrupts all relate to voltage variations. Harmonics refer to a change in the wave shape where a higher frequency is riding on top of the base frequency, which is generally the 50 or 60 hertz fundamental frequency. Interharmonics are very similar, but they aren't synchronized necessarily to the base or fundamental frequency. Transients can be very short interruptions. Fluctuations in voltage can also be a transient frequency or even transients in the waveform itself. Noise is high frequency content, also riding on the standard or base frequency voltage, and it can vary into higher frequencies and be very short durations, and it may be random also. Chroma offers a line of AC sources. It's our 61500 family. We have 10 different models available, ranging from 500 VA all the way up to 18 kVA. You can parallel these all the way up to 90 kVA as needed. They come in single phase and three-phase output versions. We have software available that'll make it easy for you to create these power line disturbances. So I'd like to get into one of the advanced features on this model specifically. The advanced features we have are we have multiple advanced features, but the programmable sequences, what we refer to as list mode, is probably one of our best features for creating power line disturbances. You can program up to 100 sequences. Each sequences can have a different time, or you can also change it to a different cycle count. The minimum sequence time is 100 microseconds or 0.1 millisecond. The minimum cycle count is 0.1 cycle. You can do different waveforms. You can program in different parameters. So the parameters are basically loaded on the software for the phase shift or phase angle starting point in degrees. It has a start and end voltage. It has a start and end frequency. You can also program a start and end DC offset, and of course you can select between two different waveforms. Here I've got it selected for cycles, so here you can put in anything from multiple cycles all the way down to 0.1 cycle or 1/10 of a cycle. Down here I've selected and ran a test for you, and I've captured it on my scope. And you can see that we started off with 3 cycles at a nominal voltage. We created some harmonic distortion for 1 cycle. We actually dropped the voltage out for half a cycle. And then we went back to a low voltage or a sag. And then we went to a higher voltage or a swell. So by doing this, we can see that we can easily create all of these different types of power line disturbances. The power line disturbances can also be done manually on the front of the unit. This is a display screenshot of the displays. I've shown 3 different settings here. Each one gives you the same parameters I showed you in the software for voltage start and end, frequency start and end, your degree setting where you want to start the waveform at, and also your waveform selection, and then count in cycles. Again, you can set the base time to either milliseconds or cycles. You can set the count from anywhere from 0 to 15,000, and you can set the sequences from 0 to 99 for a total of 100 sequences. I hope this is helpful. If you'd like to know more information about it, please give us a call or contact us on our website, and we'd be happy to go in more detail on this for you as well. And thank you.